spend too much time on that because I saw that we have some middle school teachers and we're about 60% of people already have a course. So this is the area. If I don't go into a lot of detail on this and you want some more resources to try to help you make that decision, please let me know and I'd be happy to help you or help you get in contact with people that can help. The other kind of main goal is to introduce some tips and strategies for teaching the coding concepts that come along with an introductory class. I also wanted to provide some additional research and reading resources for you if you want to continue to look into this area. And of course I want to try to answer as many questions as I can or direct you to someone or something that can. Okay, so quickly, some considerations when introducing a introductory level course. Some of the decisions that you're going to want to think about or some of the considerations are going to be how much coding do you want your students to do? Do you want this class to be just a higher level introduction to what coding is about, where it's just students are just going to learn the basics? Or do you want this introductory course to serve as a first-year class in a sequence of classes at your school? And that leads into the other decision, which is, is this class going to be the only class that you offer at your school, or is it going to be the first one in a sequence of classes? The last thing that I think is very important to consider is who is going to be teaching this class. Is it someone with extensive computer science background? Do they have moderate level of experience, or do they have no experience? That will also be a factor in what type of class you start out with. This is just a diagram that I pulled off the K-12 Computer Science Standards website, and if you look at and I know we have some middle school teachers, so this might be helpful to you as well, that middle school row, but I was thinking primarily about the high school level. These are some different ways that you could set it up. You could have all the way to the right where you only have an introductory course. You could go that middle route where you have an introductory course and some specialized courses such as robotics or app development or other coding languages if that's what your students are interested in. Or you could go the left route, which to me is what I know a lot of schools in New Jersey that already have a computer science program or sequence set up. This is what they have. They have an introductory course. They may have an intermediate course, then they have the AP Computer Science class, and then specialized courses on top of that for any students that are already finished with the AP CS class. I think Daryl Dietrich did a webinar on starting a computer science program at your school, so you may want to go back and watch that if you didn't already. I think that could also be a resource for you as you make these decisions. So to speak at the introductory level, there's a big push right now for the Advanced Placement Computer Science Principles class, and then there's the kind of, I guess, the other type of class. I don't really know a lot of specified classes here, but these are usually homegrown classes, which are more coding heavy. So the Computer Science Principles class is a bit more holistic. It talks about computer innovations and their impact on society, the beneficial and harmful effects that computer innovations might have. It talks about big data and how that impacts our society now. So a lot of different topics that you may not get into in a traditional coding heavy introductory course. When you're teaching AP Computer Science Principles, teachers don't necessarily need to be a computer science expert or have a lot of experience in computer science, whereas if you're teaching a class that's not AP Computer Science Principles, the teacher will need to at least be able to read and debug students' code. Those are some essential skills. I think that's important in the CSP class as well, but it's definitely a requirement in another type of introductory course. If you go the AP Computer Science Principles route, there are many fully developed and continually supported curriculum options that are available. On one of the handouts, I gave a link to the approved computer science principles curricula, sorry, that's out there. So you may want to scan that and see if any of those look interesting. And those are nice because they provide a lot of professional development. And code.org is one of those organizations as well. And there's also mobile computer science principles, and Joy and Beauty of Computing, which is out of Berkeley. So there's a lot of nice options if that's the route you want to go. Okay, that's all I'm going to say about making choices about what type of class to teach. But if you're thinking about what to teach, there are a couple resources that you may want to look at if you're starting from scratch to build this program. A month ago, or I'm not sure how, maybe 2 months ago now, the Computer Science Teachers Association, the CSTA, released their K-12 Computer Science Framework. So that is something that's definitely worth looking at. And there is also the CSTA Computer Science Standards. Right now, those are interim standards. Oh, I see a question. Hold on. Those are interim standards. They will be releasing the finalized 2017 version in at the conference this summer in Baltimore. So if you look at them now, I still think it's worth looking at them now. Be sure that you look at them again in July when the finalized version comes out. Oh, okay. Okay, are there any questions so far? Is there anything I can answer? I'm not sure if I got that question. Did I miss a question?
No, that was just me typing in the chat. If you have a question, you can either raise your hand.
I'm still getting used to the webinar environment here. Sorry, folks. Anybody have any questions so far? Okay, I'm going to keep going, but if you think of one, please, definitely throw it out there, and I'll get to it. Okay, so now I'm going to talk about some tips and tricks for this introductory level. I believe that it is very important when students come in to your introductory course. Often they have no experience. They have no prior experience communicating with a computer in such a way where they are telling the computer what to do through code. You have to realize that when students come into a math class in upper middle school or in high school, they have a lot of experience doing math, right? They have a lot of experience with numbers, and they're starting to work towards formulas and that type of thing. When they're in a science class, they have experience in a science class. But when they're coming to a computer science class, they often have nothing to back up to fall back on. They have no prior knowledge. But they think they do. They've been working with computers now pretty much all their lives, the students that we're seeing now, but they've been using it in a different way, right? They've been using it, the computer, as a word processor, or they've been using it for social media, or maybe for internet research. Maybe they've taken a digital literacy class or something along those lines. But all of those ways of using a computer are very different from coding and having a computer interact with your code. So I think that's important to realize when students are coming into the class. So it's important that at the beginning you're setting up the mental model of how does the computer work and how does it react to code. So to me, this is the, I guess, kind of a visual of what I want my students to understand at the beginning of the class, at the beginning of the course. I want them to understand, that there's memory in the computer, and when we set up a variable, the data in the variable is stored in memory. There's a cycle that the computer goes through as it fetches and executes the code, and that everything that happens before affects the thing, affects the steps that happen afterwards. And having that idea in their head, I think, is important as they try to learn coding and debug coding, as they're going to write their own code. So my feeling is spend a little time up front, maybe a day or two, explaining that process to students, so they are starting to get that idea in their head that it's not just a word processor, but it's something that they're going to direct what to do. The thing being the computer. They're going to direct the computer what to do. So some ideas for how you might do this. You might show some type of video that shows the execution cycle, not shows, but explains the execution cycle of the computer. You could show some type of visualization of language abstraction. I have just like a little example there on the bottom, how, as the languages get higher in abstraction, you know, they become easier for the student to write in because they don't have to understand as much of what the computer is doing. But for them to have this idea that, you know, they write code in Scratch or they write code in Python, and that gets translated down into machine language and then into I missed a step. I'm sorry. There should be one at the bottom, which is the actual binary that the computer works in. You know, I think it's important for them to realize that that is what's happening in the computer as they're writing and as it's interpreting their code. Have models for them, and have the students walk through and enact that model code through something that I call the drama. I'll talk about that a little bit later. And, you know, spend a little time teaching about binary and why it's used in computer science. You know, what's the connection between the code and the hardware? I did a webinar on binary numbers last week and touched on that a little bit. I think it's important for students to have at least some idea of how that works. Let me just say this. Some teachers feel that they need to spend time on the history of computer science at this point, talking about Moore's law and how, you know, computers used to be really large and now they've gotten really small. My personal opinion is this is not the time and place to do that. Students will not find that. I just feel like students won't find that as interesting, and it's not as relevant at this moment for them to learn the coding part of the class. You know, the only reason I spend time on this mental model is so that students have that idea to get them prepared to do the coding. Okay, part of that mental model is getting them to think in algorithms, to think algorithmically. Here is a nice definition. Let's see if I can see it. Oops, sorry. There we go. I'm trying to move the screen so I can, the dashboard screen. All right, I can't see it. So algorithmic thinking, you know, algorithms, the basic definition of an algorithm is a set of steps that completes a task. I think it's important, I know it's important to emphasize that with students up front. Algorithms are the basis of any language and any coding that we do with them, so it's important for them to be able to articulate algorithms. And I think this is so powerful because if a student thinks algorithmically, they can take that skill and they can apply it to any problem that they can think of, and they can potentially come up with an automated solution to that problem. And I think that's where the real power of computer science and the power of coding comes in. You know, they have this tool now that is a problem-solving tool that they can apply to social studies, to I have a student right now that's applying it to something for his youth group. You know, it's so powerful for them to be able to do that. So we really want to start that off and get them thinking in that way, thinking in algorithms. So some activities to help you get them on their way. These are two activities that we use at the beginning of our class. The one on the right, we call it the max of 6 algorithm, and this is something we do in the first day or two of class. And the idea is pretty simple. We give them 6 pieces of paper that are folded up, and they have to write down the steps to find the maximum number of all of those numbers that are on the folded up pieces of paper, but they have a constraint. They are only allowed to have 2 pieces of paper open at the same time. So this is a pretty simple activity. It's not too terribly hard, but it's good practice for them to figure out how they would articulate that and write down those steps. I also use it as an icebreaker activity. So students work in pairs, and I usually tell them, you know, introduce yourself to your partner and tell them, you know, I don't know, what you had for breakfast this morning, or whatever icebreaker question you wanna put out there. But again, it's starting to articulate the steps in an algorithm, and it's using something that they know how to do, right? This isn't too complex for them. So it's a nice starter program, or starter activity. The one on the left, I call computer coder. Some people may call it something else, but the idea behind this is for them to, again, think and be able to speak in algorithms. But it's also this idea that computers don't understand human assumption. They don't have human assumptions. So, you know, if you look at so let me explain the activity. On the left picture, you see some, the left images, you see some pictures, pictures that we can describe with simple words, right? House, butterfly, the thing on the upper right is actually a dog. But the assignment is one student is a coder and one student is the computer, and the coder has the picture and the computer has a blank piece of paper. The coder is not allowed to show the picture to the computer. They must use simple geometric shapes and terms to have the computer draw the picture that the coder is looking at. So, for example, the boat on the left side, they might say start halfway down the page and draw a very shallow arced, I don't know, line from the left side to the right side of the page. Continue another line at a, I'm not very good with angles, let's see, 25 maybe degree angle from the right downwards to the left. They'd have to describe the whole thing to try to get them to draw the boat. I like this activity because they can see, because the computer can't see the picture, the students really start to get that idea that they have to be very specific about the code or the instructions that they give the computer. And we have a discussion afterwards about how wouldn't it have been so much easier if you had told them at the beginning, you are drawing a boat. Okay, now let me describe to you what that boat looks like. But computers, unless someone has programmed what boat means for a computer, it has no concept of that. That is a human abstraction that a computer can't do, at least not in the programming languages we're doing. So it starts to get them in that mindset. The picture on the right with the hello, I just wanted to show you, that's an example of a student, so that the coder had the sheet on the top and the one on the bottom is what the computer wrote. And the first thing you notice is that the page orientation isn't correct. So, you can talk about that they missed that instruction. They didn't tell the computer how to orient the page to start out with. And then you can see that the H is kind of tiny there, and then there's a big E. The L's are connected, and the O is also connected to that second L. So this generates some good conversation with students about how they could have improved it or been more precise in their instructions. Another algorithmic activity that I don't have on here is to tell the robot how to get to the cafeteria. This is a variation on the peanut butter and jelly activity, if you've ever seen that one. If not, and you want to ask about it, I'll describe it later, but I'm trying to keep track of time here. So telling the robot how to get to the cafeteria, I'm the robot, and the students have to tell me how to get to our cafeteria, which is fairly complex from our room. But the activity breaks down because the students generally can't even tell me how to get out of the room, because of course they start with grab the door handle. Well, I grab it with my foot, or I'll grab it with my elbow, or whatever silly body part that I want to grab it with, and they realize they have to get more and more precise to tell me just even how to get out of the door. So again, that leads into the precision idea. And then once I kind of give up on that amount of precision, it also leads into a conversation about algorithm efficiency, because there are several ways to get to the cafeteria from our room, and I usually set a ringer in the room. I'll walk up to a student, usually an upperclassman, and I'll say, all right, when I ask this question, I want you to think of the longest way to get to the cafeteria. So that leads into the idea that there are several solutions to a problem, and none of them are wrong. It's just that some might be more efficient than other ones. So it's a nice way for them to get that idea in their head right at the beginning of the year. Also, the idea that we use algorithms every day. We don't call them that, but for freshmen that are just starting out that year, they are figuring out the algorithm for how to get from their gym class all the way up to their language class, which are on completely opposite sides of the building for us, and how to do it efficiently, how to get there before the bell rings, and so they don't get a tardy. So it's a nice way to bring that in. And lastly, I have freshmen. It's a nice way for them to reinforce how to get from around the building, because they're all pretty nervous about that. So it's a fun little activity to do with them. Another thing that encourages algorithmic thinking is pseudocode. I am a big believer in pseudocode and what I'm going to talk about next, which is flowcharts. I believe that students need to be able to articulate what steps they believe will solve the problem before they sit down at the computer and start trying to write code, especially here at the beginning when they're trying to learn the syntax of the program. So if people don't know what pseudocode is, it's pseudo code. So it's kind of English and it's kind of code. You know, it would not compile if you're using a compiled language. It would not run if you're using a scripted language. But it looks a little bit like code, and it's a nice way to express an algorithm that isn't just in paragraph form, you know, in English, but it doesn't have all the details that code might have. So I have here an example of a simple algorithm for a simple pseudocode for displaying the maximum of 3 numbers. And then on the right side, I have it, the stuff in red is the pseudocode, and then the code in black is the actual code. So I'm showing them how it translates from pseudocode into actual code. And you'll notice the step number 2 is grayed out, compare the numbers. That's because at this point in our year, they don't know how to do that. We haven't talked about how to do greater than and less than, and we haven't talked about if statements. So I want them to see that they can write some of the steps in code, and because they've broken it down in this way, they can go back, and once they've written the stuff they do know how to do, they can go back and try to figure out how to write the stuff that they didn't know how to do initially. And you know, it helps them to modularize and be systematic about writing the code that they're going to do. So I'm a big believer in pseudocode. Flowcharts, I think flowcharts are really important. Oh, going back to pseudocode, I also think it's important to model pseudocode for your students. You know, so if you're introducing a piece of model code, actual, for me, Python code, I will write the pseudocode before I introduce the program. So they have a general idea of the algorithm before they go looking at the actual code itself. Unless we're doing code reading, but that's another ballgame. So same thing for a flowchart. I will create a flowchart, and I recommend that you do this as well. Create a flowchart for any model programs that you're using. This is Wheel of Fortune, I believe. That's what this flowchart is for. So I try to always give them some type of model, and this helps your visual learners. I've had students tell me that they like flowcharts because they can see it visually. And then, of course, we want them to have the opportunity to practice doing this. So one of the things we do at Princeton is flowchart scrambles. This is not my idea. This came from Miss Elia, the other computer science teacher. She had this well before I was there. And so we have all the symbols for an algorithm, so they know what the algorithm is. And we have all the symbols here, but they're all scrambled up. And their job is to put them in the correct order. And the way that we actually do this is we use Google Drawings. So we'll give them the scrambled up flowchart. They make a copy of it, and then they can adjust that copy and set everything up in the right order, and then they create a PDF, and that's what they turn in. So this is a nice way for them to this is a nice way to scaffold the flowchart experience. You know, creating a flowchart. It's a lot of work to put together a flowchart in Google Drawings at first, so this eliminates some of that work, and it gives them some scaffolding because all the pieces are there. They just have to put them together. So I like this idea. It's a nice way to get them to do this. Okay, moving on. Some things to support beginning coders. I believe in providing a lot of models. I think that's a great idea. It's really tough for students to sit at a empty editor window and have no idea what they're doing. Some students can do it, but some students really just don't know how to start. So the way that we do this a lot of times is we'll provide a model program. So you see on the left here, this is from the book Invent with Python by Al Schweigert. I think it's the Dragon Realm program. It's one of the chapters in the book, and he goes through this program and teaches some of the concepts that are shown in here. This is what we do a lot. We'll do this, and we'll go through the code. A lot of times we'll do the drama, which I'll talk about very shortly. And then they will write their own program that's similar to this one. So they can look back at this model and think back on what we learned in class and apply those to a new programming assignment. And that's kind of the approach that we take throughout the year. And then at the end of the year, you know, they start working on more difficult programs, all the way through the year and through the second semester. And by the end of the year, they're ready to develop their own code from scratch because they've got a nice base to start from. So at the end of the year, they'll do a final project that is one of their own making. I don't tell them the idea. They come up with the idea themselves. They write the pseudocode themselves, and they program it themselves. So it's nice because they've got a nice base of programs to look at as they go to do that, but it is something of their own making. But before that, they need models. They need something to start from. You can also scaffold assignments. I'm not a big fan of doing this, and what I mean by scaffolding assignments is to tell them almost exactly what coding they need to do. So it's almost like you're doing the pseudocode for them, and then they're just filling in the coding pieces as they go along. So the example on the right is I feel like the one or two times that I've actually done this, and you'll see that the red is those are the comments. That's the scaffolding that I provided. So I basically outlined what code should go in each place, and I gave the definitions, the little pieces of modular code. I told them what definitions they should have. I don't like doing this. I really only do this as a last resort because I feel like you're taking away the opportunity for students to do that algorithmic thinking when you do this type of scaffolding. And I think that's an essential skill for students to learn. Also, what I found is that, I have one algorithmic solution to a problem, but the student may not be thinking that way. So by me outlining, what the pseudocode should look like and what the steps of the program really should be, it's almost more confusing for them because it's not the way they were thinking about it. They were going to go down a different path. So my preferred solution is to really support students, struggling students from the beginning to the end. Help them write their pseudocode, check in with them, have them write the pieces that they can write on their own, and then support them as they work on the concepts that are harder for them. I prefer to do that to this type of scaffolding. But to each his own. I guess everybody can, you can decide for yourself what makes sense. Okay, here we go. So visualizing the models, visualizing the code models that you give them, there's a couple options that I know of to do this. The first one on the left is a website called Python Tutor. It also is available in Java, JavaScript, TypeScript, Ruby, C, and C++. And the way this works is that you cut and paste the code into this website, and you can execute each line one at a time, and the website will show you, you can see there on the right, it will show you the variables and the different values that the variables have as it's executing through the code. So it's a nice way for them to see the connection between memory and the code executing. There are two limitations to this website. One is it can only handle code that's a certain length. At some point, your student's code, is going to get too long, and the visualizer crashes because it can't handle. I want to say it's 50 lines, but I'm not really sure what the limitation is. I'm sure it says it somewhere on the website. The other problem is that I believe it's an open source tool. I think it is. A lot of people like it, so sometimes when we've gone to use it, it hasn't been available because so many people are currently on it, and you're just sitting there buffering and it's not happening. And when you've built your entire lesson plan on your students being able to use that and then suddenly they can't, it's a problem. So I don't really depend upon this as much as I did a few years ago. What I do like to do is the thing on the right, which I call the drama. I came up with this idea from observing a history teacher, but I have since found out that it was not an original idea. This has been around in computer science education for a little while, I guess. So darn, I can't take credit for for a unique idea, but I still think it's a good idea. So I still think we should talk about it. So the idea behind the drama is, wait, I have a description. Let me read the description. All right, so students are given the code. And they're all given various roles for the program, in my case, a Python program. So some students act as the input to the program, and some students act as output, and some students act as memory. And then the rest of the students we break up, and they act as in Python, they're the functions. They're the little modularized codes. You might call them procedures or methods. You could even just take a straight program and divide it up and say you're responsible for this code, you're responsible for this code, however you want to break up the rest of the code for the students. And then, wherever your program starts, the student that's in charge of that stands up and they direct. They tell the other students what they should do. So if the first line of code is X is assigned 0, they will say, memory, create a label for a memory space called X. Assign the value 0 to that memory space. And it's a little bit stilted, but I think it's a useful tool because it enables students to realize that code executes and there's a time element to it, and that something that happens first can affect something that happens second. And again, it kind of gets into that idea of the mental model and allowing them to visualize what the code's doing. So the first time I do this, I do it as a class exercise. So I have several boards in my room. So I'll have, I'll have like 2 or 3 students up at the board that are acting as memory, and I'll have one student that's up at the board acting like output, and then the other students just stand up as necessary. And then once they're pretty familiar with it, I then will take them and I'll break them up into groups of 4 or 5, and that's what you're seeing there in the picture. And they have everything they need to be able to do it. They have the different assignments. The blue pieces of paper are the assignments for the students. The students have erasable whiteboards. They have the code. We do this with cryptography, so they have the mapping of ordinal values to letters, so they can pretty much handle it on their own at this point. They're pretty self-sufficient. And what's nice about this is I can usually, the assignment that I give them is something that I can quickly look at their whiteboards and say, yes, you got it, or no, you didn't get it. So it allows the students to work in smaller groups, but I can still assess them and make sure that they're understanding the concepts. What else did I want to say about this? Oh, I also like it because they're up. They're moving. They're not in front of the computer. It's an opportunity for them to move away from the computer and to interact with their classmates. And I think if we can incorporate that into introductory computer science classes in such a way that it's still educational, they're still learning from it, I think those are valuable experiences for them. Okay, I don't like lecturing. I am not a teacher by history, I guess you would say. I was in industry, so I'm not all that comfortable giving lectures, and personally I think they're kind of boring, and the students that I have usually want to get in and they want to do the coding. So 2 or 3 years ago I was at Rutgers Computer Science, CS for HS, and they gave a presentation on POGLE, which is Process-Oriented Guided Inquiry Learning, and that's an idea or a learning strategy that came to us from science that they've now taken and adapted to computer science. And the idea is that they're kind of like guided worksheets, but at the beginning students are given a visualization or some type of problem or something that they want to contemplate, and then the rest of the sheet are a series of questions to guide them through understanding that picture or a visualization or whatever it is that they're looking at. So the idea for us is that the thing at the beginning is some code, and each of the questions leads them through understanding what that code is. So on one of the handouts, I provided a link to the official CS POGLE website. There are many of them out there in many different languages and on many different topics. I've used the Python ones on if statements. I think there's one on for loops that I use. And then I've created some on my own that are kind of inspired by POGLE. So I won't call them POGLE because I've never had any POGLE training, and I have not had them approved. But this is an example of my POGLE inspired one on variable scope, local and global variable scope. And I like these POGLE activities for things like that because there's so many subtleties that I feel like students miss if you lecture on it. That I feel like these activities work because they're forced to go through and write about them in the learning activity, in the POGLE activity, and hopefully they're seeing some of those subtleties and really getting them in their head where I think they would miss them, or some students would miss them if I lectured. So I really like this. It's a nice way to do some active learning in our classes. So definitely check out that POGIL website. Oh, I forgot to say, there is some POGIL training going on in the area. I don't think it's computer science specific, but it's about POGIL and how to develop those. So I didn't add that in the handout, but if that's something you're interested in, I can track that down somewhere in my email as well. Okay, assessment, some ideas for assessment. This is assessing coding. So one of the things that I think is very important for students to realize is that they are the ones that determine if their code is finished or not. I often have students come up to me and say, am I done? Did I do everything I need to do? Well, part of being a programmer is knowing when you're done. And part of that is developing tests that if the code passes those tests, well, then it means that your code's probably in good shape and you're ready to turn it in. So one of the things that I've started doing with my students is that we create a testing document together. I've done it in different ways, but right now what I'm doing is I have a Google document that they all have access to, and each student comes up with one test case and the expected result for that test case. And after everyone's had an opportunity to contribute, I then go in and make sure it's all organized and make sure that they've actually hit all of the test cases that I would expect, and I get rid of some of the duplicates that happen. And then this becomes the rubric, basically, that I evaluate their code on. So I like it because we've developed it together. We're all on the same page as to what should be, how the code should be evaluated. I think it's a good exercise. I think it's good for them to experience that. Again, I think this testing document is for Wheel of Fortune. I think that's what this is doing. So you can see that, well, hopefully you can see that different students added in different pieces of functionality. I know what I was going to say. As the year continues, they will become more and more responsible for creating their own testing document rather than doing it collaboratively as a class. Because I think it's important for them to start thinking about the edge cases and the weird things that they have to test for. Like if they're doing math, they need to test if the user inputs a 0. Those type of things. Is their code handling those things appropriately? The other part of assessment is I have this coding convention and organization checklist, and I gave this to you as a handout if you're interested in it. This again came from my students coming up and saying, "Am I done? Am I done? Did I do all the little kind of the details, the conventions that I expect them to do?" And I want them to be as independent as possible, so I came up with this checklist that they can go through to try to make sure that they've done the things that I would expect them to do to follow convention and to make their code readable. I also tell students that if they complete this checklist, and if I can see from their code, that it reflects that they've filled in this checklist, they'll get a couple extra bonus points. And the reason that I do this is my students that are high achieving or not struggling in the class often have opportunities for extra credit because they finish the code early and they will go on and try to write some extensions. But my students that are still struggling, there's not really any way for them to gain some extra bonus points. So I like doing this because it enforces some really good coding habits. And again, gives them some opportunities to be organized about their work and to get some extra bonus points as well. It's not too many, but it's a few, which is always nice to extend that opportunity to them. Okay, I said a lot, and it's already 4:44. Does anyone have any questions that I could answer now, or anything I need to clarify? Oh, I see a hand.
Lori, you can go ahead if you want to unmute your microphone. Feel free to ask your question.
Thank you. I didn't know if I could mute it or unmute it and just type it. I was just curious to know if anyone has used any robots in their computer science classes, like the Sphero or the Finch, because they do what you were saying with your drama activity. Apparently, you can code them and they can walk from room to room or whatever you code them to do. So I was curious to know if you've ever used them.
I haven't used them. I love that idea. I totally love that idea. Has anyone else want to say if they've used it? If they've used a robot? No?
My school bought 12, I think they bought the Spheros for next year for CS principals. So I'm not sure how useful it'll be. I hope it's very useful, but I don't know how to use them. I'm obviously going to learn as I go.
So you said you bought them for principals?
Yes.
Oh, that's actually, I think that's really helpful because on the, I'll just talk about this briefly, but on the exam, on the principal's exam, part of what they have to do, if you look at the subset of, they have their own little pseudocode language that they use on the exam, part of it is that they have to do robot commands.
Okay.
So if you integrate that part of studying for the test or learning for for the test with your robots, so you could again do that algorithm idea using the pseudocode or the I keep calling it pseudocode, but whatever the language is that they're using on the exam, that's a really nice connection for them, and it's good preparation for the test. So I think that's great.
Excellent. Okay, thank you.
Thanks for that idea, Lori.
Thank you. Okay.
Anybody else?
Christine had a question that she typed in. Is there a video that shows the drama being used in a classroom?
I have one, but it's not that great. And I'm kicking myself right now because I didn't know I'd be doing this webinar. I could have done it like a couple weeks. Well, I knew I was. No, I didn't know I was doing this webinar. I didn't videotape it. It's something I plan on doing. If I do that, if there's some way that I can get that to you, I'm happy to share it with you. Sorry. And
then Donna asked, can you share instructions for the algorithm activities?
Yes, I have lesson plans for those. That's a really good idea. So yeah, I can share what I have. Actually, you don't need lesson plans. What you probably want to see is what the students, how you explain it to the students. I have that. Again, Lori, I can get that to them, right? Later?
Yeah. I mean, is this something you have now or something in terms of follow-up?
No, I have to find it. Okay. It's on another computer, so I'll have to track that down, and if everyone's okay with it, I can communicate it to you afterwards.
Okay, yeah, that's not a problem. I can
I'm on my home computer.
Yep.
But yeah, I'd be happy to share that with you. Anything else?
This isn't the end of the webinar, so don't go yet.
Yeah, don't go anywhere. I got a little bit more. Sorry, there's a lot here. All right, I'll keep going.
We will stop at 5, though, just to let you know, and we do have a link for a survey at the end, so please don't leave until you get that link.
Okay, and this stuff will go quicker. Just some general tips. When you're teaching an introductory coding language, if your language has the fact that an equal sign means assignment and equal means equality, be really careful about explaining that to your students because obviously they're coming from a math class where equal sign means equality, not assignment. So be careful that you take some time to explain that to them, and also be very careful about the vocabulary that you use in your class. So I try to be very careful about using the word assign. So X is assigned 0. Don't say X is equal to 0. People that have been coding for a while and people, I guess, I would say that have been teaching for a while have a tendency to do that, and I think that's confusing for beginning programmers. So try to be very cognizant of using the word assign and equal in the right place. Be sure you have some type of plagiarism policy. I've had incidences over the last few years. Our introductory class can be somewhat intense and students start to feel overwhelmed, and the easy solution is just to take code from the internet or take it from another student. Some students really don't recognize that this is plagiarism. They know what plagiarism looks like when they're writing, but they don't necessarily know what it looks like when they're coding. So you want to be upfront about that. I usually introduce this about a month into the class, right before we're doing our first, larger programming assignment. There's also this misconception because in industry, people have a tendency to do this all the time. They'll go out on the web and they'll find some code and they'll just pull it into their code. And And whether or not that's ethical and legal, and whether or not they're putting their own company at risk is that's an entirely different question. But what I always tell my students is I'm not assessing whether or not you can use Google. I'm assessing whether or not you know how to code. So that's not that's not the way it's going to work here. And to help them understand, because it can be kind of a fine line. You want them to collaborate, but you don't want them to take code from each other. So I have a set of scenarios that I go through, and we do them together as a class. And they answer them, and then we go over the answers just to kind of help clarify for them what's considered plagiarism, what's not considered plagiarism, when it's okay, because there are times where it's okay to take code off the internet, but they should cite that, right? They should cite and recognize that that's not their own work. So I have a set of scenarios that we go through, and then we take a little pretty easy quiz about it. I like to do this up front because I did have a student on their final try to tell me that they inadvertently left their code on a computer and another student took it from them, took it off that computer. And that was a big issue that I really never want to have again. I want to make sure that all students know up front that they're responsible for protecting their code and not leaving it, just like they wouldn't leave a test lying around on a table. They can't leave their code lying around on a computer. They need to ensure that they're putting it in the proper place or deleting it off of a computer if that's what they need to do. So I recommend you think about this up front. Other general tips: encourage your students. Encourage them to feel like they're part of the coding community. It's kind of geeky, but I call my students Python programmers. I talk about when they're going to take Java, not if they're going to take Java, which is the next course in our sequence. I like to put little cartoons at the beginning of any slides that I'm having. They're like little inside coding jokes, and students enjoy them. And I take a few minutes to explain them and ensure that they actually understand what the joke is if it's not really evident, because it makes them feel like they're more part of the community. So it's just encourage them. Encourage them to be okay with failing. I always use the example at the beginning of the year that it's like batting average in softball or baseball. The majority of people miss. More people miss than they hit the ball. And that's what coding's like a lot as well. It's very rare to get through an entire program without making at least one mistake. And that's to be expected, and sometimes it's to be honored. So the little quote I have here is, this is something that I would tell a student. If we figure out an error, we figure out what's going on, my response is, that was an awesome error. And I honestly feel like figuring out these kind of errors, it makes my day. Like, I just think it's fun when you can figure it out. And I want to encourage them to view them that way. And then if it's something that's really good and interesting and it teaches us some more, I ask, can I share this with everyone so we can all learn from this mistake that you made? And usually, they're okay with it because everybody's making them, and they're making them across the board, and we're just used to it. I make mistakes on the board. I'm not a good speller. I definitely rely on spell check, and my students know it. And I'll make mistakes while I'm coding, and they'll catch me on it, and it's okay. That's just part of being a coding teacher. You kind of have to be okay with it. And the students learn from your example that it's nothing to really stress about. Encourage them to have a growth mindset. We're running out of time, so I don't want to spend too much time on this, but I just did this today. I reassigned a program from the very beginning of the year. My students are about to take exams. They start tomorrow. So I wanted them to take a moment to look back on the first assignment that they did and to think about how they felt when they approached that assignment, because I'll tell you, they look like deer in headlights. And, to realize just how much they've learned, because now they're looking at that assignment and they're like, I could do this in my sleep. And they went back and they looked at their code and they were like, oh, my naming convention was awful, or, that while loop could have been organized better, whatever it is. But I had them just write a little short paragraph about, how much they've learned in the last 3.5 months. I think it's important to take that, to explicitly have them see that, because students don't have a growth mindset about computer science so often. I allow students to submit revised code. I tell them, anything that's coded pretty much up until the marking period, I'll let them resubmit it. That's a lot of work on my part, but I think if they're willing to put the effort in to make the corrections, I'm willing to look at it again, because that's what happens in industry. You just keep working at it until it is correct. So why wouldn't I give them that opportunity as well? And then I also, I give extra credit for enhancements, or if they're doing some type of outside work that they're really excited about, I'll try to find some way to incorporate that into the class, like just, having everybody look at it, or if there's some extra credit opportunity, trying to give them credit for that or something along those lines. General tips for you: read. If you're really interested in the field and you're new to it, there's lots of great publications and there's lots of experts out there that you can read their blogs. In the handout, I gave a set of just some initial ideas of blogs and publications and people to kind of follow. So spend some time doing that. Highly recommend join your local CSTA chapter. That's how I got into this. I went to a CS for HS workshop, which I'll talk about in a second. I met a whole bunch of people. I joined CSTA. I wasn't even a teacher yet, but they let me join. And everything kind of took off from there. I got a job, and they are a huge resource to me, the people in the chapter. They're lovely. They're all passionate about computer science. And it's just nice to have a community of people that are trying to do the same thing as you. Lastly, I would say keep learning. There's lots of great summer workshops through CS for HS, Rutgers and Keene. I've been to workshops at both of those universities, and they're great. And I heard today that, and Princeton University did one last year. I'm not sure if they're going to do another one this year. And Farley Dickinson has done them in the past as well. Definitely through TCNJ and Code.org, the partnership Laura was talking about earlier. And then the College of St. Scholastica is out of Duluth, Minnesota, but they have an online computer science education certificate program that you may want to look at doing. I'm actually going through that program myself right now. I'm in the 3rd class in the certificate program. And it's good. It's a nice way to learn some of these topics and be ready, be ahead of your students as they're going to learn the computer science principles class or whatever it is. Okay, I think that is the end of my slides. And I got it in with 3 minutes to spare. So if anyone has any questions, I'd be happy to answer them. Or I'd be happy to try to answer them.
Don't be shy. Now's your chance. And also, just to let you know, I included the link to the survey in the chat function. So if you're able to access that, it's a very brief survey. So if you could just please give us some feedback so that we know what we need to improve for next time. And once you complete your survey, I'll send you your professional development certificate. And also, we'll put you on the mailing list so that you're aware of future workshops and webinars and all that good stuff. So I do see that we have a couple of questions.
I can see them.
Yep.
Yeah. Lori, thanks for sharing the websites for Sphero and Finch Robots.
Welcome.
That's great. Thank you. And then any good sites for collaborative coding? Do you mean something like GitHub, where they can check in code and check it back out again, like version control type of stuff? Or do you mean where they're actually coding at the same time, kind of like a Google document? Rich, sorry, I'm asking Rich. Coding at the same time. No, I don't know any, and I would love it. I was actually at Google a few weeks ago at Google headquarters in New York City, and that was one of the things I asked them if, I don't know who I was talking to. I don't know that they actually could make that happen, but that was one of the things I asked for, was an educational level coding environment where students can code at the same time. It has version control. I can write comments in the code just like I do with a Google document, all those type of things. But I don't know of any. Does anybody else have any idea of an environment where students can code at the same time in a document, in a file?
Yes, I do. There's this website, IDE1. Have you used that?
No, and I don't have a pen, which is driving me crazy.
Here, let me get onto. So my supervisor sent me this. I'm going to put it in the little chat box now, if I can figure out, because I just lost it. There we go. IDE1 is a website where you can all code together. So it's how do you explain it? It's saved as like a web address, so that it's like in the cloud, and you could work on it together, or you can fork out and do your individual things. So I've been sitting in on an AP computer science class where they're learning Java, and sometimes the teacher will put code in here, and then the students can access it and then modify the code themselves.
That's awesome. Is it only for Java? Do you know what languages it supports by any
I
chance?
think they have, so I just put it in the thing. They have Java, and I thought they had Python, but now I'm confused. Let me look. Let's see. Uh, hmm. Samples. Oh, here, Java and, oh, they have everything here. Gosh, Java, C Sharp, C++, Pascal, everything.
That's awesome. And that is why I am doing these webinars. Finding out stuff like that is great. Oh, I see right down here. Oh,
Yeah.
that is awesome. All right, I'll definitely be checking that out. Rich, did you see that? Yeah, awesome. Rich sees it too. So good. Oh, that's great. I'll definitely check that out. Thank you. Was that Lori?
Yeah, that was me again. I've been sitting in on some classes, so I don't teach computer science, but I'm going to next year, which is why I'm attending all these seminars, and I'm learning everything from you guys. So anything that I have, I'll share, but like I said, I'm still learning as I go.
Hey, I'm not an expert at all. I am still learning as I go as well. I think we all are. So please share and share alike. I think that's the only way we have such a need for computer science teachers in New Jersey and in the country that's the only way we're going to get up and running is if we share stuff like this. So thank you.
Stephanie has a question. It is, what language would you recommend for an 8th grade course and its cycle class, which are only 45 days long?
Do they meet every day for 45 days or do they meet once a week? I don't know where her question is.
She's typing it in, so we'll see what she says.
Is it in the chat?
It was every day.
Oh, okay. I think I would try App Inventor, which is from MIT. It's a block-based coding language, but it allows students to create apps that they can put onto Android phones. So there's a little setup and there's some technology. You need some devices for students to be able to test it on. So there's a little investment you have to make on that part of it. But I think that's such an engaging way to get students involved in computer science because they can, if they have an Android phone, they can put it on the app and they can go to their friends, look what I did. This is really exciting stuff. And there's a lot of support, or there's a lot of tutorials and there's a lot of work in App Inventor. One of the CSP curriculums is written for App Inventor, so there's a lot out there in that field. If you don't want to do a block-based coding language, you can start with Python. I think it's doable. I'm pretty sure our middle school is starting to look to do that as well. So Python's a great place to start as well for an 8th grade class. So, and there's not as much overhead with Python. You're pretty much just installing the IDE and the Python executable file on the computers, or you might even not have to do it with this IDE one. I don't know. We'd have to look at that, but it's a nice starting point for a text-based language. Do you understand what I mean when I say a block-based versus text-based?
Yes, and she just I don't know if I'm only getting this or if you're getting it too, but she said she does the Flappy Bird game on code.org, and the kids love it, but she wants to stay away from block-based programming.
Oh, okay. Then I think Python, everybody seems to be starting in Python right now. It's nice. It's a good, can I ask why you want to get away from block-based coding? I feel like, Laura, you're interpreting for me. I can't see him.
That's my job.
Yeah.
I don't know. Stephanie, did you hear that question? Why do you want to stray away from block-based? Oh, I don't know. Maybe she can't hear us.
Okay.
She's typing.
Okay. I think people have this idea that block-based coding is incredibly simplistic. So I'm just going to tell me when she finishes typing. Mm-hmm. But it actually can do quite significant things. And App Inventor can do a lot with the phone. It can interact with other apps on the phone. It can do stuff with texting. I wrote an app where I had it, if I turned it on and if if I turned it on and a text came in, it would respond with a text saying, that I was driving and I couldn't respond right now. It's just so interactive with, they can touch the screen and they can touch buttons and things along those lines. So it's not the same as Flappy Bird. They can do so much more in App Inventor. So did she get a chance?
Yeah, she said she wanted them to have more hands-on experience with text.
Oh, well, then I say Python. I think that's a very good starting point. And I would look at the Al Schweigert books. If you just search for Invent with Python, or if you search for how to automate the boring stuff, those are two pretty good starting points. I think Invent with Python is maybe more appropriate for an 8th grade level, at least the starting ones, the starting chapters. And again, it could be a starting point for you to start with them. So I hope that helps.
Okay, well, thank you so much, everyone, for joining us. Feel free to keep asking questions if you'd like to, but I know it is